Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning. Developers will compete for the fastest lap of the day. Hope to see you at reInvent 2019.
Okay, so Assalamu alaikum everyone. My name is Ahmed Raafat. I'm a solution architect from AWS based out of Dubai. Thanks for joining us today. Actually, we have with us a special guest. Maybe this is why I switched to English. So we have Mats. Mats, he's the head of analytics in Version Mobile based out of Dubai. And he is the winner of DeepRacer circuit in Dubai Summit. So he will be presenting Dubai Geeks of DeepRacer in Las Vegas in reInvent, inshallah, 2019. So Mats as well, after I do my part, he will share with you his own experience and his tips and tricks that allow you to go and race on the virtual circuit. It's worth to mention as well that Mats not only won the Dubai Summit, he as well won the first virtual circuit that we did online. So he can share with you the similar experience that you're gonna do once you start to do the virtual circuit. Okay. So thanks, Mats and the guys for joining, and I hope everyone had a great iftar and kunafa, suhoor, all that stuff. So let's start. So I will walk you through a couple of slides about what DeepRacer is and how you can start utilizing DeepRacer. So actually DeepRacer now is become generally available. So you can go and find DeepRacer inside your AWS accounts, and that's a good thing because before you have to wait until the whitelist you, but now you just simply can create a new account or use your existing accounts, and you start to utilizing DeepRacer to train to be ready for the virtual circuit. Okay, so what is the story of the DeepRacer? Just for everyone will ask. So actually. If you look for AWS mission now, it's really focusing about the machine learning. So the mission that we have now, that we want to have the machine learning in hand of every single developer. We don't want to be only restricted to a data scientist and that stuff. We as well want every single that he have the passion and he wants to utilize the machine learning, he will be able to do that. And for that, we introduced a product called SageMaker 2 years back. And in the SageMaker, we add a feature for something called reinforcement learning. And when we had a discussion with the people in the field, that they say that usually having the tool is great, but if we have something that we can, if the guys, if you don't mind, if you can mute yourselves, yeah, that's fine. Okay. Here we go. Okay. So the idea is that people want to try it on a real field. So what we did is we built a car, and actually it's a scale of 1 of 18 car that's allow you to do autonomous driving using something we call reinforcement learning, which we're gonna learn about it today. So that's the car. It's available in Dubai, so if anyone want to see it and you are around Dubai, you can just pass to our office and I will show it to you. I hope I will be able to bring one in Saudi in my next visit, but just I need to check with the team about the export and the imports, because when we get them in Dubai, they stuck in the customs for long. Okay, good. I know it's late. I will try to keep muting as much as I can. Okay, so for that, it will be great if I bring it with me in Saudi. But anyway, for the virtual race, you don't need to have a real car with you. You can just use the simulator. You build your model, and then you start to participate in one of the open leagues that we have. There is one race is open now in London track, and I think it's still available for the next 20 or 25 days. So you can go and upload your model. And I'll show you all how you do all that stuff through the console. So what's the story of the reinforcement learning? So everyone definitely now is having the buzz and talking about artificial intelligence. And as you know, the machine learning is a part of the artificial intelligence. One of the most common machine learning application or algorithm that the people is using now in the market is something come under the category of called supervised learning. Supervised learning means that you are bringing a data set and then you label this data set and you pass it to your there is an echo. Okay, so I hope I didn't mute myself. Whoops. Okay, so then you pass this data set to your algorithm, and based on that it start to learn, and after that you send the data to it to get the response, which we call inference. The other option that you pass a data set to your machine learning, but this data it's not labeled, and that's what we call unsupervised learning. The third type of the machine learning, which we're going to focus in today, is called reinforcement learning. How we can make the machine learning to start to learn without any data set that we provided from our side. How it can start to learn from the field. Take example of the car that we are talking about it today. We need to ensure that we are, without having any data sets from the field information that the car is collected by itself, it will be able to learn. Okay, so that's reinforcement learning, and for that, this is why we start by implementing DeepRacers. Okay, and that's what I was saying: supervised, unsupervised, and reinforcement learning. Okay. Consider reinforcement learning. It's just simply how you train your dog or your own child at home. When he starts to do something good, you start to reward him. If he do something wrong, you either punish him or does not give him an award, so he will know that he did something wrong. Whole idea of reinforcement learning. And if you look to the amount of the Python code that the people writing in the machine learning in supervised compared by reinforcement, you'll see a massive difference between them, because actually the big part of what you're doing in supervised learning, that you clean up the data, you ensure it is in the right way before you pass it to your algorithm. And reinforcement, you don't need to do that because actually the data is being collected in the field. Okay. So let's go a little bit to apply what we are talking about. So in reinforcement learning, we have some terms that we need to learn about. So the first term that we need to learn about is the agent. And the agent is whatever it's a virtual or physical, that's the component that you are trying to teach it, or you try to award it to achieve a certain goal. And in our case, definitely it is the car. Okay. The second part is the environment, and the environment is the place that the agent start to navigate, to explore and learn. And in our case, it is the environment or the track. And actually the car, when it start to move, it actually move from certain location, or what we call it from certain states to another state. And that's done based on the image that's being captured, and then send it to the model, which is on the car already. And then based on that, it take a decision to take right or left. That's after being trained. During the training as well, it take this information and decide to take an action. And based on that, that's getting a new state. So state, it's just like when you move from a certain location to another location, or steering right or steering left. Okay. And that's definitely come after a certain action. Okay. And then to ensure that our reinforcement learning, it start to learn, we need to start to award it. So if it's, let's say, within the track, and it is moving to the central of the track, based on that, I start to give it an award. If it start to going outside the track, or one of the wheels outside of the track, I will start to give it less award, or maybe I give it 0, or I give it negative awarding. Okay. The last thing you need to know is something we call episode. So episode, it's a complete cycle, which means that from the moment that the car started until, let's say, hit the wall, or went out of the track, or be able to complete a certain cycle. Now, that's some terminologies that we're going to use, like agent, environment, state, action, reward, and episode. Okay, so rewarding function is the most important part, and that will be your role, and that will make your model differentiated from another models that you have within the in the competition. That how you can tweak the rewarding function to be able to give more incentives to your algorithm when it start to run on the track. If you're able to do that, then your algorithm will behave in a better way and will be able to complete the whole loop fast as it can, so you can get better results and will be able to win the race. If you look that of the rewarding function, there is a way that you say that I have my agent and I wanted to achieve the goal. And if the agent start to move and achieve the goal, you give it an award. But that's a very complex problem to solve, because in between there is no guidance for the car to know how it's going and if it's what it's doing is right or wrong. This is what they call Spear's rewarding function. What we're gonna do is, based on every certain behavior that the car is doing, let's say it's moved from state to another state, and still the all wheels of the car inside the track, I will give it a certain reward. If 2 of the wheels is outside, then I will give less. If it's very close to the central line of the track, I will start to give it more awards compared if it's moving away. And by this direction, you start to guide your model in an easier way. If you look to the previous one, this looks like you tell to your dog or your son or whatever that I will give you an award if you're able to stand and sit and run fast and bring me whatever the ball that I throw it to you. So he will not be able to know you give him an award based on what action that he did. That's actually, in this way, that will be much easier because you give an award and reward based on the action that the car is taking. So if you look, actually the problem that we are trying to solve here, it's that we are interested in creation a certain model that can be used by the DeepRacer. And we want the agent to choose which action that will be able to take to move in the track from state to another state and able to achieve the goal. That's the equation that we are trying to solve. And that's being done in a phases. So the learning itself is done on a phases. So what's happened is your agent is start to run in the simulator. Okay. By the way, the learning and all of the learning is done on the simulator itself. So even if you are had a chance to race in Dubai Summit and that stuff, there is no actual learning happen on the field itself. The whole learning is happening on the simulator. So what's happening is the car is start to move, and it's take 15 pictures per second. And based on each picture, it decided to take an action. And then take these results and start to train again and take a new action based on that. So the next slide will make it more easier for you. So we have here an algorithm that we are using. It's called PPO, or Proximal Policy Optimization. What we are doing is we are telling the car start to move, and then we capture what we call experience. And experience is combination between the current state and the action that you are taking. And based on that, you move to a new state and you get a new reward. We take this information, we save it in like a buffer database. It's like a Redis database for the people who know more in AWS. And then take this information and start to send it to SageMaker, which is the component that we use to orchestrate the machine learning. And we fine-tune the model. Then we send it back to the car, the new trained model so far, and the car start to gain a new experience. And getting this information, and again send it back to be trained on SageMaker, and the result we send it back to the car to start or deploy a new model in the car on the simulator, so it start to use it. So it's ongoing learning based on the experience that the car is getting on the field. Okay? Clear? Okay. So that's how we are doing it. We capture experience, we send it to SageMaker, it's learning, then we send it back to the algorithm to start utilizing it. So if you look mainly about, and we discussed this before, the difference between reinforcement and supervised, that in supervised we have a certain data that we are already labeled, and we know the result of that, so we train the model based on that. Reinforcement, as you saw on the previous slide, I'm taking the experience that I have, which again the state, the action, and the new state and the reward, and based on that I start to keep learning on the simulator itself. Okay. So how is say DeepRacer looks like from the back end? So when you go to the DeepRacer console, what's this behind the scene? So we'll go to the DeepRacer console now, and I'll show it to you, but you need to visualize what's happening behind this. What's happening behind the scene, that you have the interface of the DeepRacer, and it's actually have two components. It has something called SageMaker, and I have something called RoboMaker. So RoboMaker is the one that you have the simulator inside it. Okay, and that's the one that simulate that you are all the environment variables that looks like the car is running on the field. So, you know, the friction, the track, the size of the track, the environment variables, and all that stuff. And actually the one that's take the model from the SageMaker, which is the machine learning platform, and try that model to be executed in the field. And then the result of the experience, it send it back to SageMaker to fine-tune the model. And based on that, you are sending this information back to RoboMaker, and you keep learning and so on. Then we are having some additional component that's help you to better have an experience with DeepRacer. Like, you know, we keep some information in S3. All of this information is streamed to something called Kinesis video, so you can see the car while it is simulating and training. And then we have the CloudWatch, which is our monitoring solution to get more insight about what's happening in the environment. So simply, the flow diagram is that you create your model, you configure your training, then you start to train. Then based on that, you get the evaluation, and that's actually send this information back to SageMaker, which again is starting to configure the training, train, and so on until you'll finish the training. And then you have your model ready, where you'll be able to evaluate this model, as we're going to see on the console. The whole experience, or the whole thing that you need to focus in is how you are tweaking your rewarding function to have a better model. And we have some of the reward function that's available for you that you can, based on them, you can start to reward your car. So, for example, that's where is the car compared in the position in the track? Where is the car is heading? What is the waypoint? And I will show you all that stuff. What's the track width? It says like if I have the track width, I can know where is exactly I am within the track. If I am in the middle of the track, or near the right, or near the left, or outside. What is the distance from the central? What's the distance from the end line? Is all the wheels on the track? What is the speed that I'm having? You need to remember that that's a race, right? So you need to move fast to achieve your target, and you're able to get a better result. How our steering angle looks like. We recently add an online training for, that's my car, by the way. It's your training as you see it. I will come to that. But before that, we add the recent training that in this training, where it was that, yeah. We explaining for you the rewarding function in a more visual way to make it very simple. As you can still see my screen, right? Can you still see my screen? Hello, hello.
Yes, we can.
Yes, it's
Okay,
clear.
cool.
Clear.
So as you see here, so let's explore the rewarding functions. So for example here, if I say that I want to know the position, so the position actually is a function of X and Y. And that's describing the position starting from the lower left here. So I can start to reward my car when it's starting to get closer to the ends, or to be in a certain positions on the track. The other thing as well that I can start to reward is where is the car is heading. And actually the car is heading is being described as a degree, as maybe you see here. And that degree is measured the counter clockwise from the x-axis coordinates. The next parameter is the waypoint. So in every point here on the track, it's have X, Y coordinates as well that you can start to utilize. It's that to know how far you are from the end line. And maybe you start to rewarding your car when it's getting more and more closer to the end line, or as well maybe use it to give it more rewarding if it's always aligned with the waypoint, which is really cool. As well, there is something, as I told you, parameter called track width. So if I have the track width and I divide it by 2, then I will be end up by the middle of the track. So while I'm be always on the track on the middle, that will mean that I'm actually behaving well, right? And maybe I'm moving slow, but I'm behaving well. I'm not getting out of the track, and it's one of the important things as well. The other thing is how far you are from the distance. So actually you have two parameters here, something called distance from the central. And there is as well something called is it left of the central. So I can give it, let's say, 1 award if it's almost like, I don't know, 0.1 near central, then I can give it half award if it's like, I don't know, 0.25 away from the central line. The other thing as well, there is an important parameter called all the wheels on the track. That's really cool and important. And it's a very simple Boolean function that's actually true and false. So if I have, all the wheels in, that's a good sign. If I have all the wheel out, then it's my model is not behaving well. So I need to warn my model by don't give it any rewards. Then you have the speed. One of the things, and I think Matt's going to talk about this as well, is you can given incentives to your car if it's actually speeding and moving faster while it's still all the wheels on the track. And there is as well something called steering angles. So if it is negative when the car is steering to right, and it is positive when the car is steering to left. And if you need to know more about the parameters and the example of all of that, if you can just simply go to this URL, which I will share it to you, and let's say you decide that you want to, for example, write some code related to, I don't know, let's say the speed. So it will explain it to you, and if you click here, it will give you a sample of the Python code that you need to have it in your console. So that's really one of the most important things that you need to play with, and you will keep playing with all of that stuff, and based on that, you'll start to see the results. And then just let me mute. So you start to see the results, and based on that, you will be able to decide that's a good model, and you want to upload it to use it in the virtual circuits. Okay. So the next part that we should talk about is called hyperparameters. But before talking about the hyperparameter, let me show you a little bit about the DeepRacer console to get the people more excited. It's been like 26 minutes now, and it's midnight. So I don't know if the guys will still wake up, or yes, the guys is like everyone is still up, or the guys is like khalas, go and get some kunafa or something. Okay, so let's see. That's the console of the DeepRacer that I have. I have here one of the model is going on and it's doing a training now. That's some in the console here. You see the awards that my car is able to achieve so far. And you can see here the simulator while my car is going. Okay, and now it's outside the track, so it's starting again. And all of that is actually streamed from, yeah, I'm recording, so I will share this. So then all of this is streamed from RoboMaker. So I can actually go to AWS RoboMaker. So if you can go to sources and you click on RoboMaker, you see something called here simulation job. And you will find that there is simulation job is going on, which is the one that I am doing now. So if you click on this simulation job, and we are using a tool for simulation called Gazebo. So if you click on Gazebo, you will see the real simulation while it's going here. So you will see here my car, it should be moving. Just a little bit moving it. So it will be, yep, so that's my car, and the car now is moving, and I will show you my rewarding function that I just did before the call. So it looks like it's not bad, it's moving and learning, and it will keep going, and maybe by the end of the call, we'll see what was the result of that. So if you see here, it's containing, and I think it will be able to contain, oh no, it's out. So now it's starting. You see, when it's finished, that's the end of episode, and now it's starting a new episode and start to learn and learn, okay? So let's go to the DeepRacer console and see if we decided to make a new training on the DeepRacer. Just simply come and click here, create model. There will be some users and IAM things that you need to do, and you just need to as well give your model a name. So I will call it KSA DeepRacer Ramadan. Okay. Then here you decide in which track you want to train your model. So maybe you can a straight track or AWS, like a crazy track, or that's the one that's have the competition on it now. So the London track. And then you have here some actions that you need to define. Here you need to define what is the maximum steering angle that your car can take. You know, these wheels, and how much is like can be steered right and left. Okay, so I can say I want my car to steer, I don't know, maximum 20. So now it's steering less, or I can say it can be steered up to 30, which is the maximum as mentioned here. Then I can see how granularly I need my steering to be done. Do I need it to have more granularity as you see it here? And based on that, you find that I have more action items. So when I reduce my degree of steering and reduce how granularly I can do that, then I have a less action items. Or I can make it, let's say, here as a maximum, and I increase here my steering. Then I define the maximum speed. So I can say my car can go maximum of 4 millimeter per second. And as well, how granularly I want to change the speed of that. And then you start to get more actions. And that's the fun part, where you are having here your rewarding function. So that's an example of the rewarding function that we are having here. It's very simple Python code that you can see here. So quickly, it's a function. They call it reward function that we call it. And we define here 2 parameters, so the track width and the distance from the central. And then يا ده السحور ده ولا ايه؟
تعالي يا بطه هنا، تعالي اقف.
Okay. And then we decide here that if I am 0.1 from the track width, that's Mark 1, then Mark 2, Mark 3. So if I am very close to the central of the track, I will give it an award of 1. And if I am a little bit far from that, I will give it reward 2. And if I am more further, I will give it of 0.1. And otherwise, I will give it almost 0. So that's my rewarding function. And then if I'm happy with all of that, and I say, okay, maximum, train this model, I don't know, for 1 hour, 120 minutes, whatever I want, and I say start training. If you look to the one that I am running now, and I will show you what I did on that. So that's the ones running now. Let me show you my training here. So that's my rewarding function. So I did the same as well. That's having the distance from the central, but I add another thing, which is actually is all the wheels on the track and the speed. And I say that adding to that, if my car is speeding, let's say if all the wheels on the track, I will give it 1. If it's not all on the track, I will give it 0. And the other to that as well, I will start to give more incentives based on the speed. So if it's moving by around 4 meter per second, give it 1 award. If it's between 2 and 3, give it half. It's between 1 and 2, give it, I don't know, quarter. If it's less than this, it just give it 0. And just based on that, I will start to keep it running, and then I will see what is the results. So that simply is the hyperparameter, and I will leave some time definitely for Matt that he will give you from his experience. I'm sure that he will add more points on this thing. Okay. Let's head back to the presentation, because there is a couple of stuff that I need to show it to you as well. Is something called hyperparameter. Okay, so if you remember, and I was telling you here that we are using an algorithm called PPO, which is proximal policy optimizations. Okay, you don't need to know all that stuff. It's it was like, you know, if you want to dive deep and know what's exactly why we have this hyperparameter, that hyperparameter is related to that algorithm. Okay, and a hyperparameter is like variables that you need to define with a certain values before you start the training. So it's little bit different, or it's different concept than the rewarding. That's something related to the algorithm as well by itself. So let me quickly tell you what this means. Usually the hyperparameter that's there, it is good to go. But again, there is no rules of hyperparameter. There is nothing right or wrong. Just try. Maybe if you change a certain hyperparameter, that will enhance your model, or it can make it worse. And unfortunately, there is nothing we can guide you on that. You need to try it, because it's a function of how your simulation is going on. Okay, so let's quickly go through them. So the first one is there are 8 hyperparameters. The first one is called batch size, and batch size is it's actually how many data or training data that you want to group together before you start to train. And in our case is how many images, because the DeepRacer is having deep lens camera and it's captured the images. So based on the batch size, I can decide how many images that I need to combine before I start to send this as a batch to be trained on them. The larger batch, it is give you more stable model, but actually it's make your training moving slower. The default value of the batch size is 32, but you can move up to 512. The other one is epics. So actually epics is how many times you want the SageMaker or the training module to go through the data that you just batched before updating the weights. You know, end of day, machine learning is some sort of mathematical equation that's have a certain values, and that's they call it weights, and that's what we are trying to achieve. We try to achieve the best equation to be utilizing in our model. So here we're telling SageMaker how many times that he need to go through this data before he say, you know what, that's a good result that I can use it to update the existing model. We highly recommend if you are using a big batch size here, let's say you are using 256 of the batch size, that you increase your epics. The values is going from 3 to 10, the default one is 3. The other thing is related to learning rate. You need to always remember that what we are trying to do is we need to train our algorithm to minimize the error between the actual output that we are looking for with what we are predicting. And for that, we need to keep learning. And between each learn and the next learning phase, there is something called learning rate. So if you did it as a large learning rate, that's mean that you're gonna finish the learning as fast as you can, but maybe that's make your model is unstable. So you need to balance between how fast you learn and how small you learn, because if you make it a very low value, then it's gonna take longer time to train your model. The other one is really critical in the reinforcement is it's actually how you can give your model the ability to try new things. You remember we don't have any data set, right? So we need to explore the environments. So that's hyperparameter is actually give you the trade-off between how you can exploit, which is you are executing based on the certain information that you have already that you learn in the field, and between how you can exploring new things. And for that, there is two different type of categorical that you can use. So we have something called categorical exploration, and we have something called epsilon explorations. And epsilon exploration is using something called epsilon greedy. You know, I think the default one is categorical parameters, but you can try the other one as well. The one that you can play with is actually that's related to entropy. So entropy, it's mean that you are not sure about the action that you are taking. How or what is the degree of the randomization that you allow your model to choose? You remember when the car starts at the beginning, it does not have any data. So it's have to take a random action to start to learn, right? Like a small kid. that he need to learn. So what he do, he's keep trying stuff. He's like pick up stuff from the floor and start to eat it, to explore it. So if you make your entropy is like in a small value, then you are limiting the ability of going and exploring a new stuff. And that's maybe make your model don't find a new way to get a better result. So you need to balance between exploitation and explorations by adjusting this value. The default value is half, which is like in between, but you can keep changing it. The next hyperparameter is called discount factor. The other thing that we need always to remember, it's not about when I take a decision, it's not about the decision that I'm just taking now. It is that the cumulative decisions that I am taking until I reach to the end of the track, right? So like if you are playing a strategic game, it's not about the game, the step that you're taking now. It is the step that help you to take the next and the next step until you achieve your goal. So there is an hyperparameter called discount factor. By increasing the discount factor, you are telling your model to look more in the future compared by taking a decision on a smaller window of the data that it's having. The next hyperparameter is something called lose type. So actually, lose type is helping you to control how you can move from the random action that you are take to more strategic action. Again, remember that when your car start to hit the track for the first time, it need to take a lot of random action to start to learn. But at a certain point of time, that it's need to move from that randomization to start to take a more strategic action. And for that, this hyperparameter have two types, something called mean square lose and something called Hooper lose. The default one is Hooper lose, and it's actually more stable than mean square lose loss, more square loss, but you can try the mean square as well. But default one is Hooper loss. The last hyperparameter is talking about the number of episodes between each training. You remember I told you that episode, it's mean if you are taking a full cycle or a full loop, successful loop, or you are hitting a wall, or you went outside the track or whatever. So here you define how many episodes that I need to have before moving or before sending this data to SageMaker to start to be trained, and then I get this result and send it back to RoboMaker to start to getting more experience. So that's the 8th hyperparameter. I know that's maybe looks like complex one, but you don't need to change this to start to train your model. Okay, like again, as I told you, the default one should be fair enough to allow you to complete a full successful loop, but you maybe play with them to start to explore the option to get better results. So all of these things is if we back here, if you start to create a new model here, after you define your rewarding function, there is something called here hyperparameter, and you will find here the hyperparameter that we just discussed, and you can change them, and you see how this is impact your training results. Okay. Fine, cool. From here, I just will show you some useful references and then I will hand over to Mats to give you more practical from his experience. So the first thing that you can find actually is we are having here GitHub repository that's have a really valuable information. One of them is actually a workshop that's allow you to go through, or it's like a lab that's allow you to go through all the component that I just explained to you during the last 40 minutes. So it walk you through the console, it tell you how you create a model, it explain to you the actions, it explain to you as well the rewarding functions. And my advice is you start by the built-in one first, and then you start to add granularly. Yeah, I will share the links, and you start to add granularly more rewarding function, and you see the results. That, as I told you, like for me example, I started by, if it's on the center of the track, then I move to speed, then I move that's all wheels on the track, and so on. And it's give you here code snap as well that you can use it. Then it take you through the algorithm hyperparameters. All the stuff that I was talking about as well of the 8 hyperparameter is explained here. But to be honest, if you want to really dive deep and understand what behind that, go and read about the algorithm itself. Go and read about PPO. We will see more details on why we have this hyperparameters. So then once you finish all of that, now it's time to race. So if you are happy with your results, you come here to AWS DeepRacer and you click on the virtual circuit, and you'll find here there is actually London loop is open, and you can say, okay, let me see what's happening there now. So I can see on that one that's a leadership, and the leaders now is achieving 12 seconds to complete the loop, and I can see the number. So everyone is around 12 now, so that's the number that you should be looking to be able to do to get in the leaderboard. But feel free, just like, keep playing with it, start to learn. That's the whole idea, right? It's really fun to play with reinforcement learning. So once you are happy, so you say, I want to submit a model, and you give your name. I'll call it Ramadan. Okay. And then from my drop-down menu here, I will select whatever model that I have. So let's say I choose this model. I say I have read all of this, and I click submit the model. Okay. I will not be able to submit the model because we, as an AWS employee, we should not be racing. It's only for the customers. So, yep. So that's the whole thing. And once you're getting your model there, they will evaluate it. And I think you need to be able to pass 3 successful loop, so they will be able to consider you as a successful loop. And if you are win the track, you will getting a full board ticket to Vegas, including the reInvent ticket, which is $2,000. You get the airline ticket, you get the hotel, you get the pocket money, and you get as well a cash around $400 to buy a DeepRacer, whatever you want to buy, maybe Kunafa or whatever, anything that you need for Ramadan. So that's like, was a quick thing about the introduction of the DeepRacers. There is a more in the slide, but actually it's about the car itself, how the car looks like. But that will be more if you're going to race in a summit. Here is explaining to you how the car is going and what's the details of the car, what's the technology that we are using. So we partnership with Intel. We're using something called OpenVINO to able to take the images through the deep lens, and we make it ready to be able to do an inference on the car itself and that's how it looks like. We take this information, we take this the videos, we cut it down to images, we send it to OpenVINO, and we use something called ROS, so which is a robotics operating system that's running on a DeepRacer car that's allow you to do all the experience within the car. So that's from my side. So I will hand over now to Mats. Really appreciated, Mats, that you are still here. And as you see, guys, it's almost midnight, after midnight in Dubai. So Mats, if you can unmute yourself and you can share with us your experience.
Sure. Yeah, thanks, Ahmed. There's a lot more resources now than there was when we started a couple of weeks ago, right?
Yeah,
it's a lot more information now. So I wish we had this information when we first started out. It would have been a lot of help. So yeah, as Ahmed said, when we first started out, it was before the Dubai summit, a few days before. We started playing with a simulator. So I started out just like he described here, by trying out a few things, playing with the reward function, playing with the action space, which is the combination of speed and steering combination, how many degrees, and basically defining what the car can do. And then initially through trial and error, and then starting more and more to analyze the different runs and see how we're doing and what works, what doesn't work. So a few things to get started, and it depends a little bit what you want to do, right? And I guess if you want to compete to win, you need to really be almost perfect, because the times that you have there on the top of the leaderboard are basically, they've trained for quite a few hours. There was some threads on Reddit, and in general, I would say that the models that I've had that have come close to the top have been training anywhere from 15 to 20 hours in total. So just training for an hour may be able to get you to complete a lap, but it will not be able to get you to get close to the leaderboard. So the ones that, first of all, to give yourself the ability to run at max speed, obviously, is in the action speed. So you need to run at a top speed of 5 in order to be able to run as fast as possible. Generally, in order to get good times, you need to have the car always run at top speed. So what I've found is that in the models that have run quickly, I set the action space for speed to 5, and I just have either run at 2.5 and 5, but through the reward function, I push it very, very hard to always run at top speed. So that's similar to, Ahmed, I think you had that in your sample reward function, right? You had the sample of if the speed is higher than 4. So that's what I have always as well. And usually I set it to almost not get any rewards at all if the speed is less than 4. So in this case, the car doesn't run anywhere between, so it cannot run at 3 or 4. The speed, because it's a simulator, right? So it says I run either at 5 or 2.5, whereas in reality it could be anything in between. I usually set it very, very heavily towards running fast. Then the other one that I started out working with, that is the other one that you have there with all wheels on track. So initially the first runs, and that allowed me to go from initially, I think on the reinvent track, if you run it with the default settings, you'll get 1.5 minutes or something like this. But then by setting it to in a lap time, if you set it to always run, so you set it to run at 5, you push it to run as fast as possible, and all wheels on track, and you train it for a few hours, you'll usually get below 20 seconds or on the reinvent track. That's not the London track. That is for the current event, but the one that was for the preseason event. That is the first default track that they also show in the training. So that's what initially I played around with in terms of just doing a simple reward function, giving it a big reward for running fast, and then giving it a reward for staying on track, and then just letting the algorithm figure out the best way to position the car. But then what you find is, and if you go to RoboMaker, can you go to RoboMaker, Ahmed? Do you have RoboMaker
sure.
running?
Yeah. That's my RoboMaker, and that's Gazebo.
You're not sharing your screen anymore.
Oh yeah, sorry, yeah. Can you see it now?
Yes. So if you go here, I know you can drag and drop. It's a bit finicky here, but if you go see the GUI, you see there in the menu there is a GUI tab. Yeah, you click there. And then when you go to the I can't see what it says there, but you see the numbers, the X, Y, and Z position there? Yeah. So what I found is there in order to, it's quite helpful to look at the car from above. So if you enter X position 4, Y 2.5, Z 7.5, and then you skip one, and then you get the pitch. Second last, 1.57, 1.57. And then the same for the yaw. 157 is half of pi. So if you do it like this, it's easier to see the car from the top.
Yeah, that's really cool.
Yeah, because then you can really start seeing how the car is going, right? And then you can see if you look at it here in RoboMaker, you can see when you look at, and I don't know, I've spent a good few hours just staring at the one. And if you really want to burn your AWS credit and give Ahmed and the guys got lots of money, you can even run multiple simulations at the same time, and then you can have two windows. So you can do two different sets of action space or reward function, and then you can run them side by side, and you can have two windows on the same time, and you can see how they perform. But usually I would recommend, because the training costs I think about $3 an hour or something like this, right? So you do need to check a little bit in terms of keep track on your account, because it does use server processing on the back end, right?
Yeah, I think that's important to mention, because we don't want someone to get burned by that. So by default, we give you only 10 hours to be training, right? And 60, 70, yeah. So it's just only 10 hours. So be careful of that, guys. After that, we start to charge you. So please be careful.
Yeah, and so I think, and as I said, I mean, I think it's the SageMaker, but I think actually looking at the AWS bill, it's actually the RoboMaker part that is the biggest part of the actual bill, not the SageMaker part. So, but generally, I would say that kind of $2-3 an hour is for the longer training runs is quite accurate. So when you look at it like this, then the other thing that you can do, because you give the reward function, right? And then if you go back to the DeepRacer console, you can also then here see, if you look at the graph there, so here you can basically see how the model is doing, how much reward it's getting, and each point here is 1 minute. So it's showing basically some sort of function, some of the rewards by minute. And if you go up here, there is a small 3-dot line at the top right of this course. Now go down to you see the refresh button, just hover just below. Yeah, you see it there.
This one.
See the 3 buttons there? You can also see view in metrics. So if you can go to the metrics, which takes you to the CloudWatch metrics, where you can see the same graph, but then you can also see it over different time, and then you can monitor it a little bit. So basically, this is, first of all, it's showing you whether the model is getting better or not. And training longer doesn't necessarily mean that the model is getting better all the time, because at some stage the model may start declining. So you may see that the reward is going up and up and up and up, which means that the model is getting better. It's basically doing what you wanted, what you're incentivizing it to do in the Python function. But then at some stage you can see, oh well, this really didn't go well. And especially if you train over several, and if you train over several hours, you also need to change, because this by default only shows the first hour. So if you click on the timestamps, they are just above the graph. There, for example. So you can set it there to show a certain time period, or set the last, 8 hours or 6 hours, and then afterwards you can then look at your runs in order to see how it's going. So here you can zoom in and you can see. So typically you want it to start there, and then it'll get higher and higher. And then maybe also then on the hyperparameters, I have been playing a bit with the hyperparameters as well. The ones that I've been playing with, so I've increased the batch size. Typically the good models that I have are running more on 256 batch size. So that's been, if you go down there, so 256. Number of epochs, I've usually kept around 10. Learning rate, I've decreased, so added a 0 or played with the numbers to make it even smaller a few times. Entropy, I've usually kept as it is. Discount factor, I've also decreased. So some of the better models, I've gone to 0.9, which means that now with the 0.999, it tries to look 1,000 steps into the future. But at 0.9, it tries to look only 10 steps into the future. So I've found that just being a bit more short-sighted has been working quite well. But again, I need to also, I'll take your advice and read on PPO and see how it works, because even talking to some of the data scientists, I found that hyperparameter tuning is very much something that is a bit of trial and error. You just need to mess around and see. So basically what you can do here is that I would say that you start with something quite simple, and then you train it for an hour or two. And then after that, you clone the model, and then you start tuning the hyperparameters and play with it. So after you've trained the first model, so you can train it for anything from 1 to 8 hours. After that, what you can do is clone the model. The only thing you cannot change if you clone a model is the action space. So basically, you can change the reward function, you can change the hyperparameters, but you cannot change the speed and steering angle.
Let me show them this. So if we click here and click action clone, you see that I can choose different track, but this one, the action space, I cannot change.
Exactly.
I can change the reward function,
what I usually do is
hyperparameter and all of this stuff.
Yes. So what you do if you clone is basically you take it that basically as far as the model learned in the first training run, and then it starts from there. So it doesn't start from scratch. It starts based on how far it got when you ended it. So then you can basically train it on, in the beginning, I just want a model that can run on the track. So you say, I want it to run pretty fast. I want it to run close to the middle. And that's it. And then you train it for a couple of hours, and then the car will learn the basics and typically be able to run it around the track. But then you can say, now I want to tune it a little bit. And then I want to say, because obviously the way to think about the reward function is you want to incentivize the car to drive like a race car driver would do. So if you look there, for example, you see that it takes the inner corner, and now it switches to the right, which is what you would also do. And then here you see that it's quite far out. So it's actually running quite well now, the model, right? But here, typically you would want it maybe to go a little bit tighter, and then you want it to run here, and then here it goes a little bit too far to the right. So if you want a really, really good time, you need to think about, how do I want to get the car to basically drive the optimal run and take corners as quickly as possible, not go left and right too much. So that's what you need to figure out with the reward function. So you can use all of this. The waypoints is a little bit tricky, but the waypoints is basically this track that you're looking at here. I think it has 210 waypoints in total, and they all in the parameters. You can see what is the next waypoint, and then you can find out, and I'll give you that as a bit of a challenge, but basically there are ways of finding out exactly where the waypoints are. So it starts at 0, which is a little bit, it's at the right part of the bottom, and then it goes from 0 to 200, which is the 200 is the last waypoint, which is the right about where the car is about now is waypoint number 200. So you can then say that now it's around 20. So if it's at close to waypoint number 20, you want it to do this. If it's close to waypoint number 50, you want it to do this, etc. As a hint for those that want to dig deeper into it, CloudWatch is really your friend. So if you want to figure out what's actually going on with your simulation run, dig in the CloudWatch logs.
Yep.
Maybe you can show those, Ahmed. Go to the
yep. So like to just to try to rehearse what you're saying. So what you're saying is, let's say, for example, if I am in this waypoint and I want to car to really take, I don't know, steering fast to the left. So I will make like a condition, say if my waypoint is equal certain value, then steer by this angle, or like, you know, exactly. Or go ahead with that. So that's how you are actually taking a specific action, specific point to move fast on the corner, which is really make different of how the car is speeding, as you really see in the Formula One, which is really, I think it's really cool.
So go to there, go to the RoboMaker and look at the, so go to RoboMaker and then you scroll down a bit, and then there you see you have the logs there, right? So you have metrics, but go to logs. Down. There, and then that basically takes you to CloudWatch, and then you see the log for the current one. And then there, if you scroll down. So this is just when it sets up, and then you will start seeing trace, because it's tracing whenever it's running. And then basically this trace, I can't remember exactly, but this is basically a dump. So basically for every time that it runs, for every cycle, it exports the different values. And I think it is possible, I can't remember, but I dug in the code somewhere. So you can actually find which ones it is. So this one is what speed is it running, what is the coordinates of the car, and also it's even possible in the reward function to use a print statement, and then you can make your own custom logging that you can then analyze in the CloudWatch logs. So basically then you can give yourself feedback in order to be able to analyze your runs. So what I did and what I'm starting to play around with now is to you can then do a SageMaker notebook, and you can import the logs into SageMaker, and then you can even plot your runs, and you can see exactly what's going on inside your simulations. So there is a lot of cool stuff that you can do. Obviously, I mean, I've spent a good few hours messing around with it, so maybe you wouldn't start on it, but just if you want to really go for it and you want to get close to the leaderboard, you really need to dig down into it, because the difference between having a car that goes as fast as you can around the track and having a car that is close to the top 10 is a big difference. I don't know. Yeah, take a look on the leaderboard. I can't rember how.
It was 12. It was 12 seconds. It was 12 seconds.
Look at the page 2 of the leaderboard.
Yep. Let's see. So let's see in London.
Information.
Yep.
And go to page 2.
Yep. So here is 12. Let's see, page 2. 13. So,
so there I'm MC. I'm 17 now. That's my handle, MC. Yeah, that's me. So I think my best run was 12.9, something like this. So I'm about half a second closer from the guys at the top. But when you get to this level, it's really, really hard to shave off even 0.01 second or something like this. And then maybe that's the last thing I would say, is that there is a fair amount of a bit of luck when you actually submit your models as well. Because each run that the car makes is different from the other. So it's not like when you train a model, it always gets exactly the same time when you run it on the track. It's actually that if you submit the same model, you will see that it has different timings each time you submit it. So if you have a model that gets close to those times, you can submit the model every half hour. So submit it, then wait half an hour, and then submit it again, and then do that as many times as possible, because sometimes you get lucky. And that's actually what happened with the model that won the preseason race that I had, was that, I submitted it, and then all of a sudden it had a brilliant run and ended up at number 1. And then after that, I could never beat that time again, even if I kept submitting the same model. So there is a little bit of luck in there. And the same goes for the physical track, as we saw at the summit.
That's an important point. So if you are getting a lower number, that will not override the score that you already achieved, right?
No, but it'll always show your best one.
Yeah.
So submitting it over and over again is not risky for you. And in fact, as I said. So I think that the last thing maybe to say is that there is quite a big difference between running in the sim and running on the actual track. So I guess, we will have the summit in Bahrain in September. It's on the 15th of September, right?
Yeah, but I don't think there will be a DeepRacer there. I don't see it in the list.
Oh, really?
Yeah,
that's a shame.
Yeah.
That sucks.
I don't see it on the list. Like
really?
when
It's
you go
not
to
one of the 22 events?
Yeah, I don't see it there.
Oh, no.
Yeah. Summit Circuit. If I go there, I don't see it. Up to my knowledge, it's not there.
No?
So yeah, it's not there.
That's a shame. Otherwise, that would have been nice for the Saudi guys to be able to pop over to Bahrain and give it a run. Okay, then we need to organize our own internal competition. We'll get some sponsor prizes. So you need to all ask your companies to sponsor, and then we'll do our own league, and then we'll do an event in Dubai or in Riyadh. We should do that, actually. Yeah,
that's cool. That's cool.
Because there is a big difference between the track and the simulator.
But now let's the guys focus on the virtual circuit. Let's open for like 5 minutes for question. We are 10 minutes ahead of the time anyway. But like let's open for like quickly 5 minutes question, guys. If you have any question for myself or for Mats, please go ahead, unmute yourself and ask, or just put it in the chatting window. No questions? Okay.